Hi, so today we will do some numericals on lenses and combination of lenses. So here we have question number 1. Converging light rays are falling on a convex lens as shown in the figure. If the focal length of the lens is 30 centimeter, focal length is given, f is equal to 30 centimeter. And focal length of a convex lens is a positive quantity. So this is your plus 30. Find the position of the image. So when rays are converging, then such object is virtual object and its distance can be obtained. Object distance can be obtained from the point where the rays have converged on the principal axis. From this point up to optical center, this distance is called object distance. So u is equal to 10 centimeter and here object distance is positive. Now simply putting all these values in lens formula, we can find the value of image distance. So 1 by v minus 1 by u is equal to 1 by f, and therefore 1 by v is equal to 1 upon 30, and this minus 1 by u on the other side, it will become plus 1 by 10. So on taking LCM, this is your 30, LCM is 30 and 30 will go one time, plus 10 3 are 30. So therefore V comes equal to 30 divided by 4. 4 7 are 28.45 are 20. Okay. So V comes equal to 7.5 centimeter. So this was a very simple formula based question. Now question number 2. Where should an object be placed from a converging lens? So you have to find u. U is equal to what? Where should an object be placed? Here u is asked. So a converging lens of focal length 20 centimeter. The lens is converging one. So focus should be positive. Focus is your plus 20 centimeter. So as to obtain a real image of magnification. Magnification is given in this question. It is 2. And you have to obtain a real image. So when image is real, magnification should be negative. So we have to put a minus sign in magnification because real image is real. Now we know that magnification of a lens is equal to V upon U, and therefore minus 2 is equal to V upon, we are not knowing U. So the quantity which is not given should not be put with its sign. We will simply put U. We will not put the sign of U. So therefore V comes equal to minus 2U. Now we will put the value of V, F, everything in the formula of lens. Since we know that 1 by V minus 1 by U is equal to 1 by F, and therefore 1 by minus 2U minus 1 by U. Here I have not put the value of the sign of U because U is not given. So we need not put the sign in quantity U. And this is equal to 1 upon focal length is given. This is your 20. So let me take LCM of these two quantities, minus 2U and U. So it will be equal to 2U. LCM is 2U and here in numerator it comes equal to -1 minus u goes 2 times, so -2. It implies that 2u is equal to -3 into 20, and it implies that u is equal to -3 into 10, and this is your -30 centimeter. So this is how you can find object distance. Now a third question. A convex lens is used to throw on a screen 10 meter from the lens a magnified image of the object. So the screen distance is given from the lens, and this should be the image distance. So image distance V given is equal to 10 meter, and it should be positive because the image is forming on a screen and it is on the right hand side of the lens, and it is in the direction of the ray is converging in the direction of incident ray, so V should be taken as positive. A magnified image of the object is formed if the magnification is given. Okay, M is equal to 19. Now here you will see that a real image is formed on the screen. An image is forming on the screen, so image is real, and for real image magnification should be negative. Real image, so magnification is having a minus sign. Find the focal length. So you have been given V. Now we can find U by the formula of magnification. Magnification is equal to V upon U, and therefore U comes equal to 10 upon -19. So now we have value of B, we have U, and we have focal length also. Okay, we have to find focal length. Focal length is not given. So now using lens formula, in lens formula you have 1 upon V minus 1 upon U is equal to 1 upon F, and therefore 1 upon plus 10 minus 1 upon 10 divided by -19. This -19 will go in numerator, and minus minus becomes here plus. So 1 by F is equal to this much. Therefore 1 by F is equal to, let me take LCM, 1 plus 19, and this is your 20 upon 10, and therefore F comes equal to 1 upon 2. This is your 0.5 centimeter. So now next question. Now numericals on combination of lenses. 2 lenses of power plus 15 diopter and -5 diopter are in contact. The lenses are in contact with each other, forming a combination lenses. What is the focal length of the combination? So firstly, we have been given the power of the 2 lenses, so we will find net power. The power of the combination we know is equal to P1 plus P2, and this is equal to 15 minus 5 because one power is positive and another is -5. So I have considered the sign also. This is your 10 diopter. So once when you obtain power, now you can find focal length, because you know that focal length is equal to 1 upon power. And when power is given in diopter, then focal length comes in meter. So this will be equal to 1 by 10, and it is in diopter, so whole power will come in meter, and therefore focus is equal to, when you convert this meter into centimeter, this will be 100 upon 10 centimeter. That is your focal length is equal to 10 centimeter. So one answer we obtain. Now there is one more question. Question A is solved. Now question number B. An object of size 3 centimeter is placed at 30 centimeter from this combination. H is given. H is equal to 3 centimeter. And U also is given. It is your minus 30 centimeter. Calculate the position and size of the image formed. Now you have to find two quantities here. Image distance V is equal to what? And image height H dash is equal to what? So we are knowing, you can see we have focal length, we have object distance. From these two informations we can obtain image distance. Now using lens formula, we know that 1 by V minus 1 by U is equal to 1 by F, and therefore we have to find V. So 1 by V minus 1 by minus 30. U is taken negative because it is on the left hand side of any combination of lenses. So the direction in which ray is coming from the object and the direction in which we are measuring the distance of object starting from optical center, both the distances are in opposite direction. So U is taken here negative, and this is equal to focal length is 10 centimeter. From here we can find value of V. V is equal to 1 upon 10, and this minus converted into plus. When goes on other side, it again becomes minus. So this is equal to 1 by V is equal to, let me take LCM, 30, and this is your 3 and minus 1. So therefore V comes equal to 30 upon 2, that is your 15 centimeter. So one quantity V we obtained. Now we are to find image height also. So for this we will be using the formula of magnification. Magnification we know is equal to H dash upon H, and this is equal to V upon U. So now we have to find H dash. H dash is equal to V is your positive quantity divided by U, and U is minus 30, and H object height is given 3 centimeter. 3 times are 30, and this is your minus 1.5 centimeter answer. So this is how you can find image position, image height, and everything. Now one more question. An equiconvex lens with radii of curvature of magnitude RH. You have a equiconvex lens with radii of curvature RH is put over a liquid layer poured on the top of a plane mirror. On a plane mirror, a liquid is poured. This is liquid. This is your liquid. Here liquid is filled in. So now question is, the lens is put over a liquid layer poured on the top of a plane mirror. A small needle with its tip on the principal axis. Tip of the needle is there on the principal axis of the lens, is moved along the axis until its real inverted image coincides with the needle itself. The distance of the needle from the lens is measured A. Okay. When there is liquid and here you are moving a needle so that the image of the needle coincides with the needle itself. It happens at height A. Now in second case, on removing the liquid layer is removed and repeating the experiment, the distance is found to be B. Here the liquid layer is removed and the distance at which the needle coincides with its image is your B. So you have to find the focal length of the liquid lens. What is focal length of liquid? F of liquid. Lens is equal to what? And mu of liquid. These two things you have to find. Now look here. So in this first diagram, when ray from the needle comes and fall on convex lens and it is refracted through this convex lens, after convex lens plus the lens formed by liquid, the two combined lenses, when it is refracted, so it reaches to the mirror. After refraction it reaches to mirror. Now if it is retraced, then only it will be meeting at the position of, the image will be forming at the position of object itself. So the ray should retrace its path, and this happens only when the rays are falling normal to the mirror and all the normal ray are parallel to each other. The ray falls normal, all the ray when fall normal to the mirror, then only it will retrace its path, otherwise it will not retrace its path. And we know that all the normals will be parallel to each other. These rays are parallel, which are after refraction meeting at a point. So parallel ray after refraction meet at a point that is called focus. So you can say that a focus F1, better I should write combined focus. Combined focus is given F is given A, and when liquid is removed, now you have only convex lens, therefore focus of lens is equal to, you can write it F1. F1 is given B. Now you have to find focus of liquid. So you know that in a combination of lenses, the net focal length is related to the other focal length by this formula. 1 by focus net is equal to 1 by F1 plus 1 upon F2. And this implies that 1 upon A is equal to 1 upon B plus 1 upon F2. So from here you can find F2. Therefore 1 upon F2 is equal to 1 by A minus 1 by B. And therefore we should take LCM of A and B. So it comes AB and B minus A. And therefore F2 is equal to AB divided by B minus A. So this is the focal length of your liquid lens. A lens which has one surface concave and other surface plane one. So this liquid lens is a plano-concave lens because its one surface is plane and its other surface is concave. So we obtained focal length. One answer has been reached. Now second question, what is the refractive index of this water lens or liquid lens. So by lens maker's formula, we know that 1 by f of liquid is equal to mu minus 1 into 1 upon R1 minus 1 upon R2. So you have to find this mu. Focal length we obtain, we will be putting value of focal length. This is your AB, and B minus A will go in numerator. So B minus A by AB is equal to mu minus 1 into R1. So R1, you can see that it is a concave surface, so its radius will be along the side, along the direction. You can measure the radius starting from optical center in a direction which is opposite to the direction of incident ray. So here you need to take minus R. So in place of R1, you will be writing minus R and minus 1 by R2. What is R2? It is a plane surface, and radius of curvature of a plane surface is infinity. So this is your infinity. Now simplify this and find the value of refractive index. So mu minus 1 is equal to minus, here 1 by infinity is equal to 0. Any number divided by infinity comes equal to 0. So minus R will be multiplied with B minus A divided by AB, and therefore mu is equal to R into A minus B by AB plus 1. So this is refractive index of the material of liquid lens. So I conclude.